All right, so welcome to the West Texas SQL Server Meetup. This time it's virtual, and we will be discussing tonight, that is, disaster recovery, or I'm sorry, high availability and business. Okay, so for whatever reason, the questions are disabled on the right. So if you have questions, you can post a comment and I'll get back with you on the comments. I did actually set up the chat to be enabled tonight. For whatever reason, it still didn't pop up this time, unlike last time. So there's going to be a presentation for about 25 to 30 minutes. And then after that, any questions you have, just leave. Really quickly, a little bit about myself. I'm a senior consultant working with SQL Server, the cloud, primarily AWS and Azure, and of course some MongoDB as well. So document storage databases. And I do heavy development with PowerShell and T-SQL. There really isn't a language for Mongo, I guess. And then, of course, I've spent over a decade working in finance. I teach an ETL course. You can see there. You can also see it on my trailer. And I also teach a Bitcoin course as well, which is about more investing, not speculating, that is. Okay. And then, of course, I'm on social media. Most of the social media I'm pretty easy to find because you can find me with the /SQL and 6. Except for GitHub. All right, so let's get into the meat of the discussion tonight and start out with high availability and business, okay? So the good news about this one is it's not going to be super technical heavy. The next one will be more scripting, as for some of you know, that's what I prefer to do is to write code. But this one is more alongside of business. From time to time, you're going to have a client, or you're going to have, if you're a technical entrepreneur, you're going to have a wide range of clients, and they're going to be thinking about functionality as far as what they're building, but they may miss out completely on, okay, I mean, you're building something that's really great, but let's face it, how much of what you're building is going to be available all the time, right? Or most of the time, or what does your availability look like, okay? Business primarily cares about one thing, increasing profits. And there are really only two ways to achieve increasing profits. One is to save money, not spend, and the other one is to make money. Understanding this fact will help you with any business, or any meeting, I should say, with business, as you can evaluate the process in that light, okay? For instance, if you're trying to sell high availability to a business, if it doesn't meet either saving money or making money, they're probably not going to care, right? But we know that high availability does, especially with certain data, and we'll cover that in a second. So here's just some questions to consider. Number one, when can this process be down? Okay, when can the data be down? When can it be unavailable? Okay. Second, what type of data are we storing? What are we using the data for? How much profit or savings is generated from this process, from this application, from these data, right? How often will these data change or these processes change? What will our maintenance schedule look like for these data or these processes? And how quickly can we bring up another server in an emergency? Okay, or something else that's available for the business to look at. Okay, we're going to be digging in a little bit deeper into some of these questions. But for now, let's look at the dreaded, what is it, pyramid or triangle of cost, performance, and reliability. There's an old joke in business that you get to pick two of these three, right? And in some cases and in some environments, you only get to pick one of these three, right? I think about that for a second. Generally speaking, what I have found is that clients will emphasize the two that are not as important to them as they think. I'll give you an example. Very few clients will say that reliability is their chief concern. Performance tends to be one that they list, and cost tends to be another that they list. And yet when something is unreliable, that actually causes them more pain than if they spent a little bit of extra money, or if they spent a little bit of extra money on performance, right? So keep that in mind. One of the things that somebody who's highly skilled technically may not be able to parse between what someone says they want and what someone really wants. Okay. And we'll get in a little bit more on that in a second. Okay. So let's think about one of the basic questions, which is when can we turn it off, right? Let's say we have a data flow or we have data. When can clients not access those data? For those of you who've done maintenance windows, especially as like database administrators, you know that, look, I mean, some indexing operations are going to be offline, right? You're just not going to be able to access data when it's when we're re-indexing things. The same thing is if I update statistics, sometimes it's a very quick process. Sometimes it's not. It's just part of it, right? Think about managing something like the Hong Kong's live stock exchange data versus Bitcoin stock market, peer-to-peer lending, or just its currency valuation. Bitcoin never goes down, right? I mean, the peer-to-peer markets are always open. It's kind of like eBay. When does eBay close, right? Okay, if something goes offline for a period, meaning we have no or low needs for user access, then we can design infrastructure that is compatible with this, right? Think of architecture that has a high availability of system come online when it's needed versus being online all the time, right? If something's not online all the time, right off the bat, you have a reduction in cost, right? What about something that never sleeps ever? Now, robots are good at not sleeping, right? Humans need sleep. But the problem is this setup costs a lot, and it may require thinking about how we design a solution to never allow for downtime. Think of a simple activity like installing service packs on a system that can never go down. How is this possible, right? This is just a simple example of how thinking about whether we will have downtime ever changes how we build something, right? And this is one of my favorite examples of this is from Fiat League. You can see the transactions of Bitcoin worldwide. This market never sleeps. In fact, it's kind of a joke in the Bitcoin community is these people who try to trade Bitcoin overnight or something, or just at the beginning of certain times in the day. I mean, you're not going to be able to ever turn away from it because it never goes to sleep. eBay is very similar too, right? So let's ask the question, what type of data? This is another good question to drill into. Okay, we have many different versions of SQL Server and many different tools for high availability, along with other possibilities outside of it, such as NoSQL tools through Azure or other that may function better. The type of data may affect which tool we use, right? For instance, would you consider using merge replication with transactional financial data? What about availability groups? Each of these are going to come with strengths and weaknesses, and some will be more appropriate for certain types of data, I should say. Okay. Would you use transactional replication for document storage? How about mirroring? Right. The type of data will affect the high availability approach or the availability approach of those data, right? All right. Here's another one. What is the data for? Think about the following 4 scenarios. Someone in the business tells you, look, we just use it for organizing fun events at our company. Another person says, these data make up 85% of our profits. Another person says, these are documents showing employees how to do tasks. Another person says, we're able to save 43% in costs from these data. Now, right off the bat, I would say B and D, or 2 and 4 are more important, but it does depend on the business. For instance, if the business makes money through parties or just having fun, that could also be their profit, right? That's where one of the keys, I know we're in tech and people talk about technical skills, but you'll go far by being able to listen and parse between the lines. What exactly drives this business fundamentally? How does this business make money? I was working with this one guy at this one organization one time. His name was David. He was an awesome guy. But I remember one time he told me he would never hire anybody who was like super technically skilled, but didn't fundamentally understand how a business made money. He's like, if someone's technically skilled or kind of moderately technically skilled, but they know how the business makes money, he's like, they'll pick up on things quickly. He's like, then there's the people who they only know technical stuff, but they don't understand. They'll spend more time arguing about technical topics that do nothing for the business than they will doing anything of value for the business. And the point is that a business fundamentally, in order to keep employees employed, has to make money or save money somehow, okay? So each organization may view these things differently, and we need to be able to determine what's most important for organizations. And just a reminder for technical people, All right. Scott Adams, I think a couple of years ago, said something along the lines of, and I'm paraphrasing him, you cannot convince through logic. All right. You can only persuade through other means. And one of my favorite quotes by Joe Polish is, you must learn to communicate on the level in which people relate to you. So just a reminder for technical people, right? You're not going to win discussions with reason most of the time, right? It's just not going to happen. Your clients are not always going to do the most reasonable thing, especially I love to laugh. Financial clients are always trying to save money where they're making money, and they try to spend money where they don't make any money at all. And it's so backwards, right? So always document your concerns for a design. This includes pros and cons. Be wise. Don't overpromise something that's impossible, as this poorly serves you and your client. And then finally, as I like to say, recall the lessons of On the Shortness of Life by Seneca, which is life is long if you know how to use your time, right? And what I mean by that is there comes a point that if a client is torching bridges or engaging in poor behavior that he or she is later going to eat, then you should probably look elsewhere, okay? Because they're going to probably be calling you up to solve the problem, even though the problem was something that you were warning about, okay? So here's just some high availability models that we're going to be looking at tonight briefly. We're going to be looking at the active-passive model overall. We're going to be looking at the active-active model, and then what I call the active X, active Y model, okay? If you know what your business must have, then you can decide whether options like mirroring, replication, availability groups, or other options such as log shipping, etc., relative to the SQL Server version, of course, might be right for you. Now, here's what I would suggest as well, is when you speak with your clients, pause the screen and look at each of these articles. Primarily, most of your clients are going to be using 2008 R2, 2012, and 2014, right? And Microsoft provides some great documentation on some high availability options. Now, good thing and bad thing about that is they don't really talk in depth and detail about all the pros and cons of each. One of the things that I will say, though, is you should be aware when you're deciding an option. Let's say you choose replication, or let's say you choose availability groups. Really search out the gotchas. Okay, what are the gotchas? The gotchas are things that can go wrong that you didn't know could go wrong. Okay, it's very important. In fact, this week I was at a SQL Server discussion, and one of the guys there was discussing availability groups and all of the gotchas that he had learned. Now, some of the gotchas I was like, yeah, I was aware of that one, yeah, like such as indexing or whatnot. But some of the gotchas were, a shock to me. It's just like, it's like I can't, because it almost defeats the purpose of an availability group, at least in my mind. Like that's the whole purpose, is you have this really high availability or high available strategy, right? And when he was discussing some of his experience with having to manually fail things over, I was just like, well, then what is the purpose if that's what we have to do from time to time? So let's begin with the active passive model. One moment, I'm going to mute and get a drink. Now, the active passive model, one thing to note here is that this active passive model is not always just two servers. Now, in these diagrams, I draw them kind of like two database servers. But this active passive model could easily, and I mean easily, be, Y, for instance, could be 6 servers behind X, right? The key is that you have a portion that is active and you have a portion that is passive, okay? In most cases, for instance, with availability groups, you have one that's on and the other ones are either synchronized or synchronizing, okay? And you can watch that. So in the active passive model, what we have is we have an application that connects to our database. And if something happens to our database, we have something ready to pick it up, okay? So what are some of the advantages of this model? Well, first of all, it's been heavily tested, okay? Now, that does not mean that it runs perfectly. What I mean is there is a lot of support that you can find everywhere nowadays for this active passive model, okay? It is also the least difficult to maintain. I mean, replication, active replication versus mirroring is not a contest as far as I'm concerned. Active replication, people complain about that all the time. whereas mirroring is not something that people complain about quite as much. And then the other thing about this as well is that it's cost effective. Okay. Now, some of you may wisely point out, well, that depends, right? I mean, if the business is making tons and tons of money, then this active passive model may not be cost effective. And that's a very good point, which gets to some of the cons here. How much data loss could potentially happen when X fails and we have to turn on Y, or when that automatic failover occurs? Okay. Think of the synchronizing with the availability groups, right? What happens if the active one fails over, but all of the others are synchronizing? We know from the status that there's going to be some data loss there, right? So we have to keep that in mind, okay? How about rolling out changes? How is that going to happen in a passive model? Okay. And don't just think about rolling out changes on the database level, even though primarily that's what I discuss. Think about it on the app level as well. Okay. Remember that if we roll out changes on this application that is hitting X right now, that if something were to happen to X, whatever changes we made on that application have to be able to communicate with Y. Just remember that. Okay. What about maintenance? How much downtime can we have in this model if we need to, right? So consider those as just concerns with the active passive model. Another model is the active active model. And actually the next one is very similar to this as well, okay? In this image, one of the things that we can see is that we have an application, and in some cases the application connects to one or the other. In some cases we have a combination of applications, some connect to one and some connect to the other, and we basically synchronize these servers. For instance, the top arrow, and y'all can't see my mouse here, but this top arrow right here that I'm hovering my mouse on could be something like merge replication, right? And merge replication, keep in mind, there is going to be some delay between. It's closer to the active active, but it's not perfectly active active in the sense that technically you can have data that hasn't been quite synchronized when one of these goes down. Okay, so some of the concerns with the active active, I'll start with the cons right off the bat. First of all, it costs a lot of money and it costs a lot of energy to maintain active active. Okay, there are several finance companies in my career, usually with high priority data, that have done active active models. And while they're great, and while they definitely have their uses, I'm going to be the first one to admit it is a lot of work. Okay. Also, keeping both in sync is a huge challenge. There may be a delay if it's not scaled, right? The more data that I have going to X that hasn't been quite sent over to Y, but eventually has to be synced up to Y. Okay. For some business models, this is just simply overkill. I mean, think about it. Does every business model need an active-active solution? No. Okay. So some of the good with active-active things that I've really enjoyed about working in active-active environments is, number one, it allows for one server downtime. Think about it. With this model here, I can take X off, right? I can take X and start working on it. I can do what I want, right? And everybody's just going to hit Y. That's, gotta love that. Maintenance is a piece of cake with this model. Again, if I could take off X, do maintenance, get it done, bring it back online, take off Y, do maintenance, get it done, bring it back online, piece of cake, right? And then of course I say here that changes are easier. Installing service packs will be a breeze with this model, okay? And that leads me to the third model here. And this is very similar to the other model. This model is surprisingly, it's expensive and cheap at the same time. This is at least in my opinion, one of the most appropriate models for smaller environments, okay? Think of an environment that doesn't have a dev, a QA, or a pre-prod, right? They don't have one, right? They don't have those. So, I mean, not everybody can afford having 4 licenses of SQL Server running around just so that they can have 3 that are testing their environment, right? It's very difficult for some environments to afford. It's also not appropriate. I'm sorry, this is some of the concerns here. It's not appropriate for most environments, I should say, but it is appropriate, I think, for environments that don't have a dev, a QA, or pre-prod. It's also not appropriate for some applications. I mean, in this ActiveX, ActiveY model, what we have going on here, it looks like we have active-active. However, what I can do with this model is I can actually change X without changing Y, right? I can either change the application, or I can change the database, or I can change both. And I can eventually, not immediately, but I can eventually change Y, or I can revert X back to Y state, right? So the goal with the ActiveX, ActiveY model is eventual consistency, but not necessarily immediate. Okay, it's a very different approach. And people may say, well, why would you have 2 production databases, let's say, for instance, that are different, that might be different for a season of time? Well, first of all, with PII data and NPI data, some of these private data, you have a high amount of restrictions where from a legal purpose, I should say, or a legal design, you actually have to, they can only be in a production environment, right? So I can think of quite a few data sets that you don't ever want there to be a dev or a QA because you couldn't even put it in a dev and QA. And you can do all kinds of techniques with the data. That's great. But really, you don't want to actually be doing anything in dev and QA. So you actually want a model, a production model, that you have ActiveX, ActiveY, where you can make your changes to, let's say, the X, and then you can roll it out to Y or revert it back, right? And this would be appropriate for those environments, okay? However, there's a problem here, and some of you probably picked up on that, and here's another concern. You must track the changes made on X to apply to Y, or to be able to reverse, right? So think about it this way. Suppose I add a column to my database, and all of a sudden data is added into that column, right? Well, I have to track all of those data that were added when I'm ready to roll that from X to Y, right? Some of the benefits to this, though, not just illegal, is it is useful for some ETL programs, or some ETL in general. Think of API ETL, very useful for, okay? It's also useful for quickly changing data. Bitcoin is a great model. This is the model that I use for Bitcoin. In fact, Bitcoin was part of the basis of why I did it this way. First of all, I don't want to have a dev environment, a QA. No, not at all. For my own environment, I have 2 active models, and they're completely independent of each other. They're exactly the same. But because Bitcoin changes so frequently, I mean, you can have an exchange pop up, and then 2 weeks later, the exchange is just gone. And this handles that type of change best, in my opinion. Now, that's my opinion only. There's a lot of people who probably will disagree with that. Okay, so let's actually get to some PowerShell scripts now, and have some fun, a little bit of fun coding. I have 3, and on the last slide here, you can see this is where the scripts are. So one of the things to note when we were talking about high availability, and I'm going to, what I'm going to do here is move this over to the background. I'm going to come back to this slide, but I just want to clean up that background here. So, okay. So one of the things that I suggest doing with scripts, for instance, I think heartbeats are great, and they can be useful for alerts. But if you know once you know what you're going to build as far as your high availability model, build scripts and build code that takes into account that, right? For instance, as a case in point, availability groups. How many of those servers are currently synchronizing, and how many of them are synchronized? And how often are they in that synchronizing status, for instance, where there would be data loss? That's just an example of how you can build some of your tools around what you're doing. Case in point with replication, which we're going to look at right now. Let's suppose that I want to get a row count for my tables, okay? And in this case, what I'm going to do is I'm going to connect to the application database, and I'm going to get a row count for the MO table. Now, You'll notice that I'm using the row count property here, using the SQL Management Objects library, the SMO library. Quick note about that, because I get a question about this before. So we know that I have 11,163 records. So let's go ahead and let's right click. Let's go to properties. If it even brings it up in this other window, I'm going to kill it. Not really. Yeah, it did that, of course. All right, let's look at the storage. You'll notice that we have this many rows, okay? 11,163. What would happen if I said begin tran and let's delete all of them? Okay, now let's go here. Properties, storage, 0 rows. Let's go back to our PowerShell script. Let's execute it, 0 rows. But you'll know I didn't commit that transaction. So now I'm going to roll back that transaction. Okay. Down. And we still have the rows. And same thing here. We still have the rows. So my point here is that if a transaction has not been committed, this is getting it from the row count property. That's where it's getting it from, right? If that transaction has not been committed, then the row count that you obtain may be incorrect, may be inaccurate. Okay. So a funny story about that. I was watching there was a replication process going, and I think it was several hundred million records. And the table got to, I think it was like close to 300, 400 million, and then immediately went to 0. And I mean, it happened within like 30 seconds. And I was like, well, something happened. And yeah, what it was the transaction tried to push in several hundred million records, didn't commit, failed the commit, and everything got wiped out, right? Just like you saw when I did rollback tran, it didn't commit those records. Another simple one is the simple heartbeat. Now, I'm not hating on heartbeats. They can be very useful in OLAP environments, right? An OLAP environment is going to be a heavy read environment. So why not have why not do just a simple heartbeat read? In this case, what I'm doing here is I'm just heartbeating the server database. You can see I'm not going to select a bunch of records from a table, though, by the way, it depends, because if it's a heavy analysis environment, I may actually throw an aggregate out there. What I'm going to simply do is say, hey, go get me, as you can see, 36.97, go get me one column on this select top 1 star statement, right? And that is an example of, and you'll notice too as well, my connection string here is very low, right? 5 seconds and 5 seconds. Heartbeat should be a very quick turnaround. The idea is I just want to see if I go get one record out of a table from a column, that it should be very quick, right? And if it's not, if that were to take, let's say, more than 5 seconds, I would want it to fail, actually, and probably something as simple as this, I would give it 2 seconds, right? Again, whatever your environment uses, you can run a query. I remember at, what was it? One of the clients I worked with, we did these MDX queries that we would return some data on. They're very useful to see if the processes are running, because what we really want to do is we want to have kind of a robot running around the clock. Keep in mind as well that you might want to save some of these data. In this statement here, I might want to go ahead and save if it gets it, and I might want to save it in the catch block if it doesn't get it, if it fails, right? Okay, now let's look at the other one, this final one, which is something that I tend to like this approach for OLTP environments, and that is to actually run a transaction. So what I'm going to do here is I'm going to insert into this application DBO mo table a value called varchar and p, okay? So I inserted that record, and I'm now going to read. You'll notice that this command here, I'm reading where the close equals varchar from where I just sent, and I'm retrieving the open column, right? You'll see it's p, and we know that's what we inserted. We inserted varchar and p. Now, in an OLTP environment, what I prefer to do is a transaction, okay? And my argument for doing a transaction is the fact that I want to know if the process, in an OLTP environment, as many of you know, there's a lot of different processes that are happening behind the scenes, right? It's like you put data into this table, then there's analysis done, and then it gets sent over here, and then analysis is done, and then it gets sent over here, right? Or think about a trade, right? I'm going to go buy these shares of stocks, and those are going to then go here. It's going to execute. The broker's going to sign. Then it's going to send back a confirmation. I get the confirmation, and then I own those shares, right? Stock trading is a great example of OLTP. Well, I want to be able to see my transactions go through. So the heartbeat that I use is going to be, in my opinion, what I want is a transaction. I don't want to just read from a table. That's more of an OLAP thing. Here, let me just go get this sum of here, right? Same thing with replication. The reason why people use miscounts or mismatches, I'm sorry, between source and destination is it's a good heartbeat, right? I mean, if it's offline, it's offline. And by the way, going back to this script here, I want to point out that this script right here, I have used a derivative of this script. And when it takes a long time to get access to the data, or it takes a long time to get the information, it is offline, right? It is a very useful heartbeat in and of itself. But with an OLTP environment, because it's a high transactional environment, I want to actually run a transaction and then read that output. What that does mean, though, is that I have to think about my database design, right? Because suppose, let's just say hypothetically, I don't have any way to know that a transaction was not real. Well, what am I going to do? And by the way, this is where MongoDB or DocumentDB, excuse me, in Azure is just heavenly, right? Because since it's schemaless, you can have at the very end of that, you can have a field that says test, and you can easily filter that out in your application. Okay. So I also put here design in a way that keeps you free until issues arise. The next virtual meetup or meetup, whatever we do next, I want to cover what I call next step scripting or next step design. So it'll be a lot more technical than this, and it'll be a lot more code, which is what I prefer to do. And the reason is because one of the things that I've observed is that people, look, anybody can create an alert, right? An alert is just noise when you fundamentally think about it. Think about creating meaningful alerts, okay? Let me give you an example. If you have an alert that says, oh my gosh, logs are full, that's a meaningless alert, right? What are you going to do if your logs are full? Well, there's only one thing we can do, right? Assuming you're in that type of environment. In some environments, I don't want to know my log is full because it's supposed to all be simple recovery. So if there's an active transaction, oh well. I was in an environment like that one time. It was so funny, but it solved a lot of the problems. So think about the next step, and that's the next presentation that I have in a few months, hopefully, is going to be about next step coding, because there's no reason to have an alert for the sake of having an alert, right? An alert is just noise. An email is just noise, right? So whether you send out an email, whether you get a text, whether you get a phone call, it's noise, right? So design these things. Design whether it is your heartbeat, a transaction, mismatch. Design it in a way that keeps you free until issues arise. I'll give you a really final example on this point. Is I worked at this huge environment, and they did a replication mismatch report. And I thought it was funny because they reported matches. And I asked the guy one time, I was like, why are y'all reporting when something works? He didn't know. He was like, I don't know. I've never really thought about it that way. But it's like, you want to know when something fails, right? Imagine if SQL Server every single 30 seconds said, hey, all 7 of your databases are online. And then 30 seconds later, hey, all 7 of your databases are online. I mean, that would get annoying really fast, right? So the reason why they call them error logs. So just consider that, because one of the things you want to try to minimize the amount of noise and the amount of alerts you get. Otherwise, you just start training yourself to turn things off. All right. Cool. So there is the scripts. The great thing about YouTube is the video will be up on YouTube, and you can pause it at any time. I'm not sure why the chat box didn't pan out tonight. But either way, you are able to leave a comment, and I'll try to get back to you as quickly as possible. And the hope on the next meetup is that it will be in a couple of months, let's say March or April. And if we can do that, that will be great. And otherwise, y'all enjoy your evening. And it looks like we hit about